Welcome to physics class, and we are talking about the kinetic energy of this bowling ball versus ping pong balls. And here's what the question basically asks. This is chapter 5. And this problem is sample problem 5B on page 173. It says a 7 kilogram bowling ball moves at 3 meters per second. How much kinetic energy does the bowling ball have? That's question 1. We're going to do that right here. Then it says, how fast must a 2.5 gram ping pong ball move in order to have the same kinetic energy? I'm going to let you guys try that, but let's do the first one together. So we start with our formula. This will be the bowling ball. Bowling ball. And kinetic energy, as we do in science, we always start with the formula because that gives us a place to put everything. We are solving for kinetic energy, and everything else is pretty much spoon-fed to us. We have 7 kilogram bowling ball, so that's going to go right there, 7 kilogram. The velocity is 3 meters per second, which is in the correct unit, so we're good to go there. And we just calculate this. So this is going to be 1/2 times 7 times 9, which is 1/2 of 63, which winds up being 31.5, 31.5 joules. That is, of course, the unit of kinetic energy. 31.5 joules is a 7 kilogram bowling ball. That's a 16-pound bowling ball moving 3 meters per second. That would be a classic bowl it down the lane type speed. So this is the kinetic energy of that. Now, this question wants to know if you have a 2.45 gram ping pong ball, how fast do you have to move it to make it have that kind of energy? So you could technically take a ping pong ball and knock bowling pins over with it if you got it going at a certain speed. What we want to know is how fast that speed is. I'm going to pause the video. You try to work this out. We're back now. Hopefully you had a chance to figure that out. But the first step in this is to convert this ping pong ball gram weight to kilograms. And we would, of course, divide this by 1,000. And it would become 0.00245 kilograms. And that's going to be our mass in this problem. The kinetic energy, of course, is this. So we plug in 31.5 joules equals 1/2, that's always going to be there, by the way. That's 1/2. Times 0.00245 kilograms times v squared, which we don't know. All right? So doing some math here, 31.5 equals half of this. 1/2 times this is 0.001225. As annoying as it is, we need to divide by that. And beware rounding all this, because if you over-round this number that I'm writing right now, it is going to alter this answer severely. After dividing, 31.5 divided by this, you will get this answer. And then, of course, you have to square root both sides. And after you do that, our velocity is somewhere around, according to the book, around 160-ish meters per second. Now, is that a realistic ping pong ball speed? No. You know, this is somewhere between 250 and 400 miles per hour, and but it, you know, theoretically could knock bowling pins over with that. You guys have a great